The National Electrical Code, or NEC, does specify when double strut is required based on conductor size and quantity. NEC 392.12 APWO addresses this directly. It states that where the sum of the cross-sectional area of the conductors on any strut exceeds 40% of the cross-sectional area of the strut, a second strut shall be installed parallel to the first strut. This provision aims to ensure adequate support for conductors, especially when a significant number are present on a single strut. There are several reasons behind this requirement. Firstly, larger conductors are inherently heavier and exert a greater load on the support structure. A single strut might not possess sufficient strength to bear this weight over time, potentially leading to sagging or even structural failure. Secondly, large conductors are more prone to generating heat, particularly when carrying substantial electrical currents. This heat can gradually weaken the strut material, compromising its load-bearing capacity. Thirdly, larger conductors are often more vulnerable to physical damage from external factors like impacts or vibrations. A single strut might not offer adequate protection against such damage, whereas a double strut configuration provides enhanced security. Installing a second strut parallel to the first distributes the load more evenly and provides additional support and protection. This minimizes the risk of accidents, ensures the long-term integrity of the electrical system, and promotes safer operation. It's crucial to verify your local building codes because they may have additional or more stringent requirements beyond the NEC. Always consult with your local building department to confirm specific regulations applicable in your area. When in doubt about the adequacy of a single strut support system, opting for double strut is a prudent approach. It is generally advisable to err on the side of caution and utilize double strut whenever there's uncertainty regarding the rack's capacity to handle the conduit and wire load. This proactive measure contributes to a safer, more reliable, and more durable electrical installation. To further elaborate on the application of NEC 392.12 APWO, it's important to understand how to calculate the cross-sectional area of conductors and struts. The cross-sectional area of a conductor can typically be found in the manufacturer's specifications or in relevant tables within the NEC. For struts, the cross-sectional area will also be specified by the manufacturer. You need to ensure you are looking at the internal area available within the strut. To determine if the 40% threshold is exceeded, sum the cross-sectional areas of all conductors on the strut. Then compare this sum to 40% of the strut's cross-sectional area. If the conductor area exceeds this value, a second strut is required. Consider a scenario where multiple runs of large conductors are bundled together and supported by a strut system. The weight of these conductors, combined with the heat they generate under load, can place significant stress on the support structure. Using a double strut system in such cases not only complies with NEC requirements but also provides a greater margin of safety and reliability. Furthermore, the NEC provides guidelines in the spacing and installation of strut supports. Proper spacing is crucial to prevent excessive sagging or deflection of the conduit and conductors between supports. The specific spacing requirements will depend on factors such as the size and type of conduit, the weight of the conductors, and the environmental conditions. In areas subject to seismic activity, additional support and bracing may be required to withstand earthquake forces. Consult with a qualified engineer or electrician to determine the appropriate support system for your specific application, especially in seismically active zones. Maintaining proper grounding and bonding is another critical aspect of electrical safety. The strut system should be properly grounded to provide a low impedance path for fault currents. This helps to minimize the risk of electrical shock and equipment damage in the event of a ground fault. Use appropriate grounding clamps and conductors to ensure a reliable connection between the strut system and the building's grounding electrode system. Regularly inspect the strut support system for signs of corrosion, damage, or loose connections. Corrosion can weaken the strut material and reduce its load-bearing capacity. Damaged struts should be repaired or replaced promptly to maintain the integrity of the support system. Loose connections can create electrical hazards and should be tightened securely. Document all inspections and maintenance activities to track the condition of the strut support system over time. Keep records of repairs, replacements, and any modifications made to the system. This documentation can be valuable for future reference and can help to identify potential problems before they become serious. Consider using cable trays in situations where a large number of conductors need to be supported. Cable trays offer a convenient and organized way to route and support cables, and they can often be more cost-effective than individual conduit runs. The NEC provides specific requirements for the installation and support of cable trays, including guidelines on fill capacity, spacing, and grounding. When using cable trays, ensure that the cables are properly secured and supported within the tray. Use cable ties or other approved methods to prevent the cables from sagging or shifting within the tray. Also, be sure to maintain adequate spacing between cables to allow for proper ventilation and heat dissipation. Proper labeling of conductors and conduits is essential for safe and efficient operation of the electrical system. Clearly label all conductors with their circuit identification and voltage rating. Label all conduits with their contents and destination. This will help to prevent confusion and errors during maintenance and troubleshooting. Use durable, weather-resistant labels that are easy to read and understand. Consider using color-coded labels to further enhance identification. Proper planning and design are crucial for a successful electrical installation. Before starting any work, carefully plan the layout of the conduit and cable runs. Consider factors such as the available space, the load requirements, and environmental conditions. Create detailed drawings and specifications that clearly show the location of all conduits, cables, and support structures. Obtain all necessary permits and approvals before starting work. Comply with all applicable codes and regulations. Work closely with the local building inspector to ensure that the installation meets all requirements. Invest in quality materials and equipment. Use only UL listed or otherwise approved products that are designed for the intended application. Avoid using substandard or counterfeit products, as these can pose a safety hazard. Use appropriate tools and equipment for the job. Use the right size conduit bender for the size of conduit being installed. Use a torque wrench to tighten connections to the proper torque. Wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and hard hats. Follow all safety procedures and precautions. Work in a safe and organized manner. Keep the work area clean and free of clutter. Avoid distractions and stay focused on the task at hand. If you are not sure how to do something, ask for help from a qualified electrician. Do not attempt to perform electrical work if you are not properly trained and qualified. Working with electricity can be dangerous, and it is important to take all necessary precautions. Continuous learning and professional development are essential for staying up to date with the latest codes, standards, and technologies. Attend training courses and seminars to enhance your knowledge and skills. Read industry publications and online resources to stay informed about new developments. Obtain certifications to demonstrate your competence and professionalism. By following these guidelines, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and regulations. Remember, electrical safety is everyone's responsibility. Taking the time to do the job right can prevent accidents and save lives. Let's consider another example to further illustrate the application of NEC 392.12 at war. Suppose you have a horizontal run of strut supporting 6 500 kc mil conductors. Each 500 kc mil conductor has a cross-sectional area of approximately 0.7781 square inches according to Chapter 9 Table 5 in the NEC. This makes the sum of the conductors 6 multiplied by 0.7781, giving us 4,686 square inches. Now, let's say the strut you are using has a cross-sectional area of 10 square inches. According to NEC 392.12 at war, if the conductors occupy more than 40% of the strut's cross-sectional area, you need a second strut. 40% of 10 square inches is 4 square inches. Since the conductors occupy 4,686 square inches, which is greater than 4 square inches, you would need to install a second strut parallel to the first to provide adequate support. It's important to note that the cross-sectional area of conductors can vary slightly depending on the manufacturer and the type of insulation. Always refer to the manufacturer's specifications or Chapter 9 of the NEC for the most accurate values. Also, remember that the 40% fill requirement applies to any strut in the system, not just the main support struts. If you have branch runs or individual supports, you need to check the fill percentage for each strut to ensure compliance. In addition to the NEC, there may be other applicable standards or guidelines that you need to follow. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for cable trays and other electrical equipment. These standards can provide valuable information on the design, installation, and maintenance of electrical systems. Consult with a qualified engineer or electrician to determine which standards are applicable to your specific project. Remember, the NEC is a minimum standard. In some cases, it may be necessary to exceed the NEC requirements to ensure a safe and reliable installation. For example, if you are installing conductors in an area with high temperatures, you may need to use a larger conductor size to compensate for the dirting factors specified in the NEC. Similarly, if you are installing conductors in an area subject to vibration, you may need to use additional support and bracing to prevent damage to the conductors. Always consider the specific conditions of the installation when designing and installing electrical systems. By following these guidelines, you can help to ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and regulations. Electrical safety is a shared responsibility, and it is important for everyone to take the necessary precautions to prevent accidents and protect lives. Consider the arrangement of your conduit runs and how they affect the loading and the strut system. If you have multiple conduit runs stacked vertically, the lower struts will bear a greater load than the upper struts. In such cases, it may be necessary to use larger struts or additional supports to distribute the load more evenly. Similarly, if you have long spans between supports, the struts will be subjected to greater bending forces. In these situations, you may need to use shorter spans or increase the size of the struts to prevent sagging or deflection. Pay attention to the details of the installation, such as the type of fasteners used to attach the conduit to the struts. Use fasteners that are specifically designed for the type of conduit and strut being used. Ensure that the fasteners are properly tightened to prevent the conduit from slipping or coming loose. Use lock nuts and washers to provide a secure connection. Inspect the fasteners regularly for signs of corrosion or damage and replace them as needed. Consider the impact of environmental factors on the strut system. In areas with high humidity or corrosive atmospheres, the struts may be subject to corrosion. Use corrosion-resistant materials or coatings to protect the struts from the elements. Inspect the struts regularly for signs of corrosion and take steps to prevent further damage. In areas subject to extreme temperatures, the struts may expand or contract, which can put stress on the connections. Use expansion joints or other methods to accommodate thermal movement. The NEC provides specific requirements for the installation of electrical equipment in hazardous locations. If you are installing electrical equipment in a hazardous location such as a chemical plant or a petroleum refinery, you must follow the requirements of Article 500 through 516 of the NEC. These articles provide detailed guidance on the selection, installation, and maintenance of electrical equipment in hazardous locations. Work closely with a qualified engineer or electrician who is experienced at hazardous location installations to ensure that the installation meets all applicable requirements. Proper coordination and communication are essential for a successful electrical installation. Communicate clearly with other tradespeople, such as plumbers and HVAC technicians, to avoid conflicts and ensure that the electrical system is properly integrated with other building systems. Coordinate the installation schedule to minimize disruptions and delays. Attend regular job site meetings to discuss progress and address any issues that may arise. Document all changes and modifications to the electrical system. Keep accurate records of all materials used, test results, and inspection reports. This documentation will be valuable for future reference and can help to troubleshoot problems or make future modifications to the system. Train your employees on proper electrical safety procedures. Provide regular training on topics such as lockout/tagout, arc flash protection, and safe work practices. Ensure that all employees understand the hazards associated with electricity and know how to protect themselves from injury. Enforce strict adherence to safety rules and regulations. By following these guidelines, you can create a safer and more productive work environment. Review and update your electrical safety program regularly. As new technologies and regulations emerge, it is important to update your electrical safety program to reflect these changes. Conduct regular audits of your electrical safety program to identify areas for improvement. Seek feedback from employees and other stakeholders to continuously improve the program. Staying proactive and engaged in electrical safety is essential for protecting your employees and preventing accidents.